Hello, welcome to FA.O. In this TA series, we are going to work on ladder logic programming in TA portal. In this video, we will create a dual starter, ladder logic, and SR flip-flop, and we will simulate it, and we will explain the difference between SR and RS flip-flop. First, you need to open TA portal version 17, shortcut. Now it's showing the existing projects. We previously created a Now it's showing the existing project. In previous video we created a project and we done the hardware configuration. If you want to check that video, you can check it in the below description link. This was a project we created, project 4. You need to click on that. You need to click to open the project, and we already done the configuration. So we are done doing the hardware configuration. Here, opening the project view, click on that. Now the project is opened. Now you can see the CPU, the tree view. You need to open that. Go to device configuration. Select the module. Zoom it. Yeah. Here there's input starting from I 0.0 to I 1.7. This output is starting from Q 0.0 to Q 1.7. It's a 16-bit input model. It's a 16-bit output model. We are using these two models for the today project. Now you can go to the programming blocks to create the program. Defaultly main OB1 will be there in the project. Defaultly it's a ladder logic. I will show you how to create a new block and change the programming language. Click on add new block. Yeah. Now the name was there. You can change the name whatever you want. And organization blocks, different OBs are there. The programming cycle is a continuous task. It's having continuous scan cycle. Others are interrupts. Based on the interrupts it will works. We will explain it in other videos. And the language was mentioned. So LED is ladder logic, FBD is function block diagram, STL is structured text language, SCL is structure control language. In this project we are going to explain on ladder logic. We will select LED and the programming cycle and click OK. Yeah, you can see that OB1 123. Next, if you create a other one block on programming cycle, it's shown like 124, OB 124. We only require main OB1 for this project. We will delete this OB 123. Click the delete button and click yes to delete. Now it's deleted. It's showing the. You can give the network name. It's a good practice. It will easy for troubleshooting. You can give the network name. They will give a network name. You can give the commands also. It will add logic. You can click the run. Here the favorites will be there on the top. You can select whatever you want, drag and drop it. Select NC, drag and drop. Then you can click here also, click here, and you can add by clicking, just clicking it. We will select the NO and we will select the output coil. And these are the inputs, these are the output. Now it's created. For the latching, here the open branch is there. You need to click here and just click here. Branch was created and just click normally open contact and connect it. Now the wired logic. Now the wired logic was created. You can give the tag names. Create, yes. After giving, yeah, we have given the tag names. You can copy it here and you can paste it. Now we given the tag name. Now we need to give the addressing. Addressing, you need to click that tag name and right click, define tag. Here global memory is selected. You need, it's a physical input we are going to give. That's why we need to give global input. For that, it will give the automatic addressing based on the model we configured. Define tag. Now start button, start PB, you are going to define tag. Actually, if the wiring you are done, you need to configure based on the wiring. If start PB is connected to I0 point, while double clicking it, we can change that. But in this case, we don't require. Define tag, and for the output, you need to select it and define tag. It's a global output. It's automatically fetching define tag. Now just changed and it's all reflected here also. Now this wired logic is completed. Next we will do a SR flip-flop. Yes. You can get in shortcut also. We will take it in bit logic operations. Go to the basic instruction and open bit logic operation. Scroll down. You can find SR. This is a SR flip-flop. Double click it. Yeah, it will be in the network too. Yeah, here the SR flip-flop is here this R has highest priority, reset has highest priority, and set has lowest priority. In RS flip-flop, S having highest priority and R having lowest priority. Actually, in this PLC program itself, last line having highest priority. Here, last line is R reset. That's it's having highest priority. Here we will add tags. We will put NO for start. Start maybe 2. We need to give unique names. In this output, you can configure here itself. But now we configured it. We need to define tags. Here you can on the section you need to click and you can select global input like we done already. So automatically fetch contactor. So output. Click here and give global output. Yeah. Now SR flip flop and your wire logic is finished. Actually, the difference is it's same. This execute says here we done. It's kind of wired diagram. It's we don't recur it. We can here itself. It's a neat and clean, and we can use it with the SR flip flop. This latching was reduced here, and for the stop button, I given NC. It's in the wired logic normally, but in this real scenarios, stop button they wire NC, and if it's wired NC, we need to give program NO. Stop button we need to give for NO. Put the cursor there, you can show that drop down menu. In the drop down menu, select it, and you can change to NO. But in this case, we are not going to connect into physical inputs. We are going to simulate with the simulator. Due to that, we don't record that. We will change to NC itself. And for the SR flip flop, it was if the physical input was wired in NC, you need to configure here NC. In this case, we are not giving that. That's why we are giving NO only. Based on the instruction, the NOs and the NCs will change. Yeah, we created it. After that, you need to compile it to check whether any errors are in the program. Compiling is finished. Zero errors and zero warnings are there. It's ready to go. After we done the programming, we can simulate it with simulator. Before simulating, you need to install PLC Sim in your PC. The downloading link for PLC Sim was given in the below description. You can download it with that link. For simulating, you need to click on this PC start simulation icon. Click it. Enable simulation support. Click OK. It's showing that starting simulation will disable all other online interfaces. This is no problem here because we didn't connect it with any other devices. You can click OK. Yeah, now the PLC sim was opened. Now the PLC sim was opened and it's showing to select target device to download. Here the configure access node was there. It's a default address in the CPU. If you want, we can change the IP address. The IP address and the interface. PN is Profinet interface and it's connected to slot 1. And this is CPU model 1500 series and the device name. You can click on the select target device here and you can start search to find the target device. Now our CPU was detected. This is in its in physical device was there. We can check it with flash LED. It will flash. If we click this tick mark, it will be flash. And you can load. It's with selecting this thing. You need to load the project. Download this program to PLC. Yeah, consider the trusted. Yeah, it's showing consistent download. We can select. We can click load. Now the configurations are loading. Yeah, it's showing that start modules. You can here no action is there. We can start module like it will run when after downloading. Not required. We will do manually. We'll click no action and finish. Click finish. Now the program was loaded. You can go for the run mode. Now the PC in run mode. The run button is in green color and click go online. After going online, the tick mark is coming. It means that your project is downloaded correctly. After that, if you want to monitor this thing, this ladder logic, you can click this monitoring on of its kind of goggles icon. You can click it. Yeah, now it's in the monitoring mode. Yeah, here it's due to the stop piece NC. The logical continuity stops with the start button. If we press it, the contactor will on. Flip flop also like that. It's till start button. The stop PB was not there. That's why it will the logical continuity stops before the start PB. Now we can simulate it. For simulating, if we need to force the inputs, for forcing that, we can for the simulator we need to switch to project view. This icon to click switch to project view. Now the project view was opened. Now the project view is opened. You need to click here for creating new project. Here, click in this icon. Yeah, it's giving project name. Whatever project name you want, you can create. Just click it and create. Now it was creating the project. Now the project was created. Go to sim table and you can go for sim table 1. It's now empty. You can add the project tags by clicking load project tag, this icon. All the tags you are configured in the PLC program will reflect here. Yeah, now it was loaded. You can close it. Now you can move it. I will moving. Yeah, here this start PB1 is mentioned and stop PB1 was mentioned. You can force it. If you given start PB1, Yeah, give start PP1. This contactor will be energized, and this latching contact will be latched. Once we remove start button, once we remove the hand from the start button, it will be the logical continuity will be there via the contactor one latching NO. We can click stop to stop it. Yeah. It's in the wire logic diagram. Now we are going to the flip-flop. So it's a flip-flop. Yeah, the flip-flop is there. Yeah, here it's a start PB2 is mentioned here. So we need to put start PB2 to make it on. Yeah, now it's on. If we remove that start PB2, also it will be on. Here there is no need of a latching contact because there's a SR flip set reset flip. Once the S is true, this will SR flip flop will set. When the reset is true, it will be reset. Now in this case, we removed start PB2. Now we will give stop PB2 to stop this. Yeah. Now we remove also it will be stop the condition. But I will show you. Click start PB2 and stop PB2. Now here that it was not on because in this case SR flip-flop reset having highest priority. If we given both input, the reset having highest priority, it will be reset. It was continuously resetting. In this PLC program itself, in this TIA portal, it's actually last line having highest priority. Now we can remove both and we will check with the RS flip-flop. Minimize it, go to offline to change the logic. Now you can click here, just click here. This orange icon is showing. Move the cursor there and this drop down menu is showing. You can just click and change to RS logic. Okay, yeah, here giving we can connect it, but it was not set. It's R and S. You can change to stop. This was stop PB2. Actually, how we need to do is just we need to click it and double click and there is a icon is there. Click here. Now we need to change to start PP2. After creating that, you can click here and compare to check any errors are there. Zero errors and zero warning is showing. Now it's okay to download. Then you need to click this download button. You don't want to start simulator again. Your already simulator was open. You can directly go to download. Download to the device. Click load. Or just download it. Go online. All are fine. The monitoring view. Yeah. Now you will open the simulator. This give you start. It will start like a SR flip-flop. Remove it and stop. It will stop. But if you're giving start and stop both, here set having highest priority, so it will be set continuously. This is the difference between SR and RS flip-flop. In this way, you can try with different logic. We will check other features in next video. Thank you.